All right, in the last video we learned about the servo and real quick introduction to how it works, how to get it connected to our robot, and then in the code how to control the position that it's at. Remember, the servo is one half of this part that we're going to be adding to our robot, which is a way for the robot to look around its environment and then gather information about distance that it sees. So in this video we'll talk about this component, the ultrasonic distance sensor, and how it works. So here I've got one that's not connected to anything right now. The sensor has what looks like two eyeballs, but really they're, you can think of them as a speaker and a microphone. And it uses like echolocation, kind of like a bat here. It's going to make a sound out of one that's too high pitch for us to hear, and the other one is going to listen for the echo of that sound coming back. The time that it takes for that sound to travel, bounce off something, and return will allow us to calculate the distance, because the speed of sound in air is usually pretty constant, especially for small distances like we're going to be measuring. So let's get this connected to the robot first, then we'll take a look at the code and see some data from this just to kind of prototype it and get it included in our larger robot program so that we can use it in the later videos. So there's 4 connection points on it. Usually they're labeled right on here. If they're not, you can always look up a data sheet if you can find a part number on there. And there's tons of great tutorials that go more in depth here on the internet that you can find. So the 4 pins are VCC, that's going to need 5 volts, ground, which is going to need to connect to ground, and then a trigger and an echo, which are actually used for the creating the sound and listening for the signal coming back. These are pins, so we're going to want some of the type of jumper wires that will go over those. And what I've actually done is taken some pin to hole jumper wires and attach them together to increase my overall length. So I've got some longer ones I can work with here. The colors again don't really matter, but I like to put black on ground if I have it, red on VCC, and then a couple of other options that are just different for the trigger and echo pins. Okay, now that we've got those attached, where do they go on our robot? Well, 5 volts, the VCC. We solved the problem of only having the one 5 volts on the Arduino by breaking that out over here on our breadboard. So I'm going to add it into one of those unused holes in there on that parallel connection. I've got the relay plugged into that and the servo, and then one wire going back to the 5 volts. So all in parallel. Ground, we're going to run into a similar issue that we had with the 5 volts. You may have used up all 3 grounds on the Arduino already. I have. One ground was from my servo, one from the relay, and one from my throttle. So I'm going to solve it the same way we did the 5 volts by taking an extra jumper wire, plugging it into one of the grounds on the Arduino, and taking that over to an unused row on my breadboard. I unplugged the 5 volts of my servo, so I'm going to add that back in to that row as well, and the ground from my ultrasonic distance sensor that I'm holding. The trigger and echo will be determined by our code in terms of what we plug them into on the Arduino, but you can use any of the digital input-output pins. I'm going to put trigger into 11, which is my green wire, and my echo into 10. All right, so we got that connected. Let's switch over to the code now and think about what we want to do to make this thing work. First off, we're going to want to add some variables to the top of our code that are important to keep track of for the sensor. So I'll kind of group these together. Make sure I'm above void setup. We're going to need to declare a pin that the trigger is connected to, so I'll call that trigger pin, and I plug that into 11. Another integer here, which was the echo pin, and I plug mine into 10. But you can always redefine those here later on if you just are good about keeping track of this. Other things that are going to change, so they're going to be variables, would be the amount of time it takes for that sound to go out and come back, right? Because that's a critical thing in our calculation of the distance. So a good name for that variable would be duration, right? The amount of time that happens for. And the type of variable here is going to be slightly different. We're going to use not an integer, but a long, which is essentially very similar to integer, but just a bigger number. It takes up more space on our kind of limited memory that we have on the Arduino, but we're tracking this in microseconds, so it can end up being a really large value, and we don't want it to overflow accidentally. Lastly, another integer here is going to be the result of the distance, and the way we're going to do our math using the speed of sound in air and this duration variable is in centimeters. So I'll call this distance cm for centimeters. Like that. There we go. Cool. You'll notice that these two variables, I haven't set them equal to anything. I've just declared them. So that allows me to assign them a value later in the code, but they don't need to have some starting value like all these other variables did. It's a bit of a difference from what we've seen so far. I forgot to mention this before, so I'm adding this little section in as well. As we set up the ultrasonic distance sensor, it's important that we define the pin mode of our trigger and echo. So in the setup function, make sure you include that. The trigger pin will be set as an output. It creates the pulse. And the echo pin, which is listening for that signal coming back, will be an input. So make sure you add those functions. All right, so here's the operation. We're going to go all the way to the bottom again, past all of our user-defined functions, and create a new user-defined function that we can call whenever we want our sensor to measure the distance in front of it. So similar format here, we need to say what does the variable or the function return when we call it. So far, we haven't had any of our functions actually return anything. All they need to do is what's between their curly brackets. With this distance function, we want it to return the distance. So that is going to be an integer type of variable. So instead of saying void, I say int. Now we get to give our function here a name. Something descriptive is always good. I'm going to call mine getDistance. Set of parentheses where anything that's required to make this function operate would need to be declared here. Like the point turn function, we needed to know how many iterations of that to do. With getDistance, we actually don't need any input, so we can leave those parentheses blank. We need them there, but we can just leave, not put anything in there. And finally, getting into the meat of it here, what actually happens when we call this function, so between the curly brackets. First of all, we want to set the trigger low, like give it a chance to quiet out the sensor and make sure that it's not creating some mistaken noise that would affect it. So we do that by using the digital write function on the trigger pin, and setting it low will make it so that the speaker part of our sensor isn't making any noise. We want to hold it there for a second. So we could use delay, but this happens really quick. So delay takes inputs of milliseconds, thousandths of a second. We can actually use delay microseconds, which is much, much more precise and fast. So just 2 microseconds. It's like 3 orders of magnitude smaller than the milliseconds. All right, so that quiets things down. Now we're going to pulse that trigger pin. We're going to make a sound by writing it high, holding it there for a short amount of time, and then low again. That'll kind of like create this little vibration in the air. So it is going to use these 2 functions again to start with. So I'm going to put those in there. The pulse begins by going high. We'll wait there for 10 microseconds and then write it low again. So quick little on off of the trigger. Creates a high pitched sound we can't hear with our ears. But it's moving out away from our sensor towards something that it can reflect off of. Now we're going to start timing how long it takes until the echo is heard. Start timing how long until echo is heard. And there's a built-in function that makes this really easy. It's the pulse in function. It's part of the built-in vocabulary of Arduino. Essentially, as soon as we call pulse in, it starts a little internal stopwatch, if you will, until a condition is met. And the condition we want is when the echo pin goes high. All right, and that's going to happen when that sound, that particular frequency of sound, hits like the microphone side of the ultrasonic sensor, and it creates a little electrical pulse, makes it go high. So in order to like track this time and like be able to use it, we're going to use our duration variable and set it equal to whatever that amount of time is. All right, so remember we declared duration as a variable we could use up at the top. Coming back into play here. Finally, we do some math. We've got the time it took for that sound to be created, go out, hit something, and bounce back. And because the speed of sound is fairly constant in air, we can use simple physics here. If velocity is distance over time, distance would be velocity multiplied by time. Here's what that math is going to look like. We'll take the time, the duration, multiply it by the velocity that thing was moving at, which in our case is the speed of sound in air. So 0.034 is how fast sound moves in centimeters per second. Lastly, we're going to divide that whole thing by 2. And that's because we don't want to know the distance that the sound actually traveled, which was down to the object and back. We want to know half that distance. Just how far away is it? Remember, the sound actually has to travel back and forth, so it gives us, twice the distance. We'll just take half of that. So just like we did on the line above, we need to like capture the result of this math. So I'm going to set that equal to our other variable we declared at the top of our code there, distance centimeter. All right. So distance is equal to time multiplied by velocity, and we're going to take half that value so we don't get down and back. Cool. Very last thing we got to do here. Remember, when we call get distance, we want it to actually return this distance of value. So it's not going to do it automatically. We have to tell it to do that by saying return distance cm. Cool. And that's it. So just a few lines to write there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Really just 9 lines of code to define this function. Let's check it out. All right. So let's go up to our loop part of our code here. First of all, I'm going to make sure I've got nothing else going on at the end of setup here. I've got my test routine turned off, so the motor's not going to run. Just in my kind of end of the loop here, let's use that get distance function. When I call this, it would return that value, that distance, to the program. If we actually want to see it, we better put it somewhere that we can see. Let's put it to the serial monitor. So I'm going to use serial.println, and I'm going to print the result of this get distance function. That'll happen pretty quick, right? Because the Arduino runs, rapidly. It's a computer. So let's put a delay in here of 200 milliseconds, fifth of a second between each value that we get. Let's upload this and see if we made any typos. It says trigger pin was not declared in this scope. Trigger pin. How did I write it at the top when I did declare it? Trigger pin equals 11. Oh, trigger. I forgot my R. There we go. Another typo here. Distance cm. Did I make a typo there? I did. The joy of working in an integrated development environment. That's very helpful. All right, my code is uploading. And once it's uploaded, we should be able to open up our serial monitor and see some of the data coming in. And hopefully we'll see it's pointing kind of up at the ceiling right now. And as I move my hand in front of the sensor, drops down there, moving my hand closer, moving it further away. So we do get a few random values in there for sure, as sometimes it bounces off an object a little bit randomly in the room there. But it looks like my ceiling's maybe 1.5 meters above, or it might be hitting the light bulb that I have over my camera here. We can see we could use these values here to kind of navigate around a space and get a sense of what direction has more open room in front of it. So now we've learned how to get this ultrasonic distance sensor working, the servo working. We can use a little hot glue to attach these two together and make something that looks like this. So we're able to actually move that sensor around and measure some different directions. In the next video, I'll give a little insight about how to make that work. And the code that we can use to make the robot decide which way to turn.